morning everyone, my name is Zuha. Today's my seminar video represent topic is Rolley's theorem. So statement: if f of x is a function of the variable x such that f of x is continuous in the closed interval a comma b, f of x is differentiable for every point in the open interval a comma b, and f of a is equals to f of b, then there is at least one point e such that f dash of c is equals to 0. This is the statement of Rolley's theorem. And proof: we need to know closed interval and open interval. An open interval is an interval that does not include its two midpoints. The open interval x is a is less than x or less than b is denoted by a comma b. Closed interval: a closed interval is an interval that includes all its limit points, a finite number a and b. Then the interval x is a is less than x and x is less than b. So it is denoted by closed interval a comma b. Let us see how it is. Case 1: if f of x is constant, then f of x is equals to k, which is constant, and f of a is equals to k, f of b is also equals to k. So f of a is equals to f of b. Since f of x is equals to k, therefore f dash of x is equals to 0 and f dash of c is also equals to 0. Case 2: if function f of x will first increased and then decreases, then at some point c, consequently f of x will be maximum. Then f of c minus h is less than f of c, and f of c plus h is less than f of c. F of c minus h minus f of c is less than 0, and f of c plus h minus f of c is less than also 0. F of c minus h minus f of c by minus h is greater than or equals to 0, and f of c plus h minus f of c by h is less than 0. Taking limit on both sides, limit h minus less than 0 and f of c minus h minus f of c minus h is less than or equals to 0, and limit h minus less than 0 and f of c plus h minus f of c by h less than or equals to 0, and limit f dash of c is less than greater than or equals to 0, and or f dash of c is less than or equals to 0. Limit f dash of c is equals to or f dash of c is less than or equals to 0 and f dash of c is equals to. Case 3: if function f of x will first decreased and then increases, then at some point c, consequently f of x will be minimum. Then f of ch is less than f of c and f of c plus h is greater than f of c. F of c minus h minus f of c is greater than 0, and f of c plus h minus f of c is greater than 0. F of c minus h minus f of c by minus h is less than 0, and f of c plus h minus f of c by h is greater than 0. Taking limit on both sides, limit h minus greater than 0 and f of c minus h minus f of c by minus h is less than or equals to 0, and limit h minus greater than 0 and f of c plus h minus f of c by h is greater than or equals to 0. Limit f dash of c is less than or equals to 0, and r dash of 0 is greater than equals to 0. Limit f dash of c is equals to r dash of c is equals to 0, and here f dash of c is also equals to 0. So this is the problem. Verify Rolley's theorem in the internal 2, 4, open interval 2, 4, closed interval for the function f of x is equals to x power 2 minus 6x plus 8. Solution: given that f of x is equals to x square minus 6x plus 8. So a comma b or 2, 4, a is equals to 2, b is equals to 4. By Rolley's theorem, f of x is equals to x square minus 6x plus 8, and f dash of x is equals to 2x minus 6. After differentiating, we get 2x minus 6, and then f dash of c is equals to 2c minus 6, and f dash of c is equals to 0. 2c minus 6 is equals to 0, 2c is equals to 6, and c is equals to 3 in 2, 4. Here a is less than c is less than b, hence Rolley's theorem is verified. So these are the applications: to improve the existence of stationary points, to check differentiability and continuity of a function, to find points where the tangent is horizontal, to prove that existence of Woods equations, to verify the Rolle's theorem. Thank you.